Hey guys, so today's LeetCode Daily challenge I was not able to do. Um, I always struggle so much with these like bitwise problems. So I definitely need more practice on it. I had to watch some videos on how to do this problem, but I did want to still try to do it by myself, even though I kind of know like the approach and just like talk about it, I guess. So I guess it's a good learning experience for me. The whole idea is that we are going to be given some sort of array, and they want the longest nice subarray. So subarrays mean that they're contiguous. So we just can't skip elements. We have to include them in the subarray. And what does it mean to be nice? It means nice if we bitwise and every pair of elements in the subarray and they're equal to 0. So this it's going to look like this, right? Like 1, maybe in the beginning, 1 and 3. Maybe if we and that into 0, and if so, we can move on to maybe 1, 3, and 8. And then we could keep like expanding our result, right? They want the longest. Let's just say this doesn't work. Then maybe we have to shrink our window and shift it up like this. So problems like this, it's kind of the part that I could contribute is definitely going to need some sort of sliding window technique. But usually with sliding window, it's very easy. Like, what are we going to add to our window? What are we like? Sorry, whenever our right pointer goes to like a new spot, we add that to our window. Whenever we were ready to remove left, we take it away from the window. But in this case, what does it mean to like remove slash add to the window? That's where I got stuck and I didn't know like how to solve it. And that's when we have to know a couple properties of this like bitwise operators. So one thing that we will have to use for sure is right like bitwise and. We definitely need to use bitwise and then I'm thinking like we need some sort of current, maybe like current bits, right? And the whole idea is that when we in our window, we want to make sure that all of those bits never overlap. Yeah, for example, like if this was one of the numbers and then this was another one of the numbers, that would be valid window, right? Because they don't overlap. Like all of this would be valid. So in order to store our cur bits, we kind of want to, I guess, OR everything, right? Because when you OR everything, it just kind of brings down, like if it's 1 and 0, it will just bring the 1. If there's a 1 on that column, it will bring it down. So so let's just say we ORed everything, it would be 0, 0, 1, 1, 1, 1, 1, right? So I think this would be our current bits. And that would be our window. And then every single time we want to add the right to the new window, we want to check if, okay, maybe if this was our current bits and this was our left and we want to remove, right? So this is, we want to remove 1010000 from the cur bits because we're about to shift left over. Then we can XOR this maybe. So it would be 0, 0, 0, 1, 1, 1, 1. Okay, so we can use XOR to remove the left number from the cur bits. Okay, that's cool. How do we add to the thing? Or like, how do we know that the window is valid? Let's, I guess let's just say this is our current window and we're about to add this. if we and it together, we want a 0. So if the cur bits anded with the like cur num is not a 0, then it's not a valid window. And then basically if the cur bits anded the cur num is a 0, then we have a valid window, right? And then how do we add to this window? We just use or to add to our cur bits, right? And then what are we going to be adding? We're going to be adding, like, it's going to be the right pointer. Like, let's just say we had 0, 0, 1, 0, 0, 1, and we want to, if this was our cur bits, and we wanted to add, we wanted to add something like this. We just needed to updated cur bits. Right, we just need to OR everything, so it would be like this. Yeah, okay, then we just use OR. Okay, so that makes more sense. Yeah, I was like stressing out yesterday about this, but everything that I wrote here makes sense to me now. But that being said, we're definitely going to use some sort of sliding window to solve this problem. We just need cur bits. I don't know, maybe cur bits starts out at 0. Longest is 1. I think they say like one number, right? A subarray of length 1 is always considered nice, so I guess longest can be 1. We're going to return longest for sure. Sliding window means there's 2 pointers left and right. For right in range, want it to be n is the length of nums in range n. Okay, so now we process right, and I think what does it mean to process right? We want to add right to the yeah, we want to add right to the window, right? Process right. What does that mean? Add right to the cur bits. More explicitly using OR, right? Yeah. So we're going to say cur bits or equals, right? Oh, and this is nums at right, because right is a pointer. Okay, so now we need to, I guess, check if our window is valid. So I think that's while the cur bits not equals to 0. While cur bits not equals to 0. Wait. That's something I didn't really think. How do we know if our window is valid? Oh, I guess we can't really do this without checking if it's valid first. So we can't really process right before checking if it's valid. Because, I don't know. Wait, let me see. So if the cur bits anded with the cur num is the cur num is nums at right. If we and it together and we see that it's a 0, if we see it's 0, then it's valid. Then we want to add our thing to it, right? So cur bits or equals nums right, else not valid. So not valid means while cur bits and nums right is not equal to 0, we want to shift left up. So shifting left up means we have to remove the nums at left from the cur bits, and then we could do this using XOR, right? So we just do cur bits XOR with nums at left. And then I guess after all of this, we're guaranteed that it's valid, right? Everything at this point is valid, is a valid window. So we could just say longest is equal to max of longest, or right minus left plus 1. I think that's it. Let me run it. Oh, I didn't shift left up. Ugh. Okay, we removed left, but the most important thing about the sliding window is that we shrink it. We have to shift left up. Let me run that again. Okay, index out of range, it's because left is going up. While left is less than n, and should it be left is less than right? I don't know. Maybe everything at this point is a valid window might be a bad claim. I think if it's a valid window, I should just check if it's the longest right then and there. Let me just do that. So now that it's not working, I'm inclined to just draw everything out. So they expect 1. My output was a 2. Okay, and we're going to use sliding window to do this. Let's see. So left is 0. How am I going to do this? Left is 0. Right is 0 as well. For right in range, this. If cur bits, I guess cur bits is 0, right? Cur bits is 0. If cur bits and nums at right. Nums at right is 3. So that's 3 right there, right? So if it's 0, if we AND those, yeah, that's going to be a 0, right? Because 0 and 1 is 0. Then it's valid. Cur bits or equals nums. So now my cur bits is just going to be 1, 1, like right there. Longest is going to be 0 minus 0 plus 1. So longest is just going to be 1. And I'll just keep longest at 1. Okay. Now it's going to move to the next one. Now right is going to be 1 right here. So we're going to check if cur bits ANDed with 1 is equal to 0. It is not. So it's going to be going to here, while left is less than right. And cur bits and nums right is not equal to 0. Well, yeah, it's definitely not equal to 0, right? So we have to shift left up. First we need to make sure that nums at left, which is 3, is XORed. So I need to XOR this. And when I XOR this, it's going to basically set cur bits to 0, right? Because if they're the same, it's just 0. So it's going to be like that. And then now we're going to shift left up. So now it's like this. Then while left, I guess left less than equal to right. Let me run this again because we should be able to check again right here. No, okay, that still didn't work. Okay, and cur bits is not equal to 0. Well, it is equal to 0, so we're just going to move on. Okay, now we move on, which means right is going to be 5. It's going to be 1 and 5. Cur bits is back to 0. We want to now check 5, which is 4, 1, 2, 4 and 1. If we AND this, we get a 0, right? Wait, but what? Oh, this is weird. Why is my cur bits back to 0? That's not good. Yeah, I'm doing something wrong. Look at the tutorial. Oh. Since this was good, I was like clearing things out, right? We still need to add cur bits the nums at right. Or the nums at right? Is that what they did? We have to OR it with the nums at right. Which, since it's in the if and the else and we do the same operation, that's why we could just take it out, I guess, and do it like this. Let me run that. I think I did a pretty good job like working with these like bitwise things. I'm really bad with these. I definitely need to practice more. But I think with this problem, it might be very specific, but it's like, when do we add right to cur bits? I guess what does this mean? Like, just because it's a valid window doesn't mean we should add cur bits right away. Or if it's not a valid window, we want to bring it back to 0, right? We want to bring it back to 0 before adding the nums right to our current cur bits, and adding as in or equals. So I guess a summary of this problem, there's a couple like, I'll call it like bitwise toolbox things that hopefully I will retain. One of them is obviously like the AND. Another property is like n XOR 0 just gives us n. And that was good for to remove the left, right? We could use the XOR to remove the left. And then we could also use OR to just bring over the right. And then we use AND to check. So this is a quite involved problem that I guess I just need more practice on. So yeah, thanks for watching.